Welcome to Laws of Probability Part 2, and the last thing we need to be looking at is looking at if two events are independent. So what we were looking at before, we were looking at mutually exclusive, and now we're going to have a look at if the events are independent of each other, if the occurrence of one event does not affect the occurrence of the other. So another way of putting this is that the probability that A occurs, probability of A, remains the same given that B has occurred. So we know that the probability of A occurring is the same as A occurring with the condition that B has already happened. So we remember that the probability of A given B is the same as the probability of the intersection of A and B over the probability of B. So now instead of writing the probability of A given B, I can just say that that's probability of A, because that's what happens if we have independent events. Now if I just rearrange this equation by bringing the probability of B across to the other side, I end up with probability of A times the probability of B is the same as the probability of the intersection of A and B. And that's if we have independent events. So let's have a look at what this actually starts looking like. What we have is we have some cards written on identical pieces of card again, and we're placed in a bag. A is selected at random from the bag. Let A be the event of an odd number is chosen, and let B the event that a square number is chosen. So let's have a look at what this one's actually going to look like. So let's draw a Venn diagram to show this. So we're going to draw our rectangle first. Oh, it's a great rectangle. Yours is going to be much neater than mine. And let's have a look at this. We've got A and we've got B and we've got our universal set. So A is an odd number is chosen. So what are the odd numbers? The odd numbers are 3, 5 and 7. And 9 is also an odd number. But for B, it's a square number as well, because 3 squared is 9. So a square number are the numbers that when you square a smaller number you get to. So if 9 would stay there, that's what it is. The other square number we have is 4, because 2 squared is 4. And then we've got these other numbers, 8, 6 and 2, who are sitting out here. So part B then says, determine whether A and B are independent events. So we know that they're independent events if the probability of A times the probability of B is equal to, and let's just work that out first, the probability of A occurring is there's 4 things out of 8 numbers altogether, and then the probability of B occurring, there's 2 things in B out of 8 things altogether. So if we place this into our calculators, what we end up with is 1 out of 8. Now, the other part to this is the probability of A intersects B. And if we look at the A intersects B, there's one way of it occurring out of 8 things happening altogether. So because we now satisfy this, we can therefore say that A and B are independent events since the probability of A times the probability of B equals the probability of A intersects B. And I think I've gone off the screen and you can't see it. So let's have a look at question 2 then. Here's a similar question, but now we're not asked to draw any diagrams. We've just been given some information and we're being asked now to find P. We're given the probability of A, we're given the probability of B, and we've given the union of A and B as P, and we're asked to find P if they're mutually exclusive. So for them to be mutually exclusive, we know from the previous video that means that the probability of A intersects B has to be 0 for them to be mutually exclusive. So using the formula of the probability of A union B is the same as the probability of A plus the probability of B minus the probability of the intersection of A and B. So we know that A union B is P. We know the probability of A is a half. We know the probability of B is a third. And we know that this probability of A intersection B has to be equal to 0. So if we work this out, we actually get that P equals 5 out of 6. And this is using our laws of probability. So if I'm now going to attempt to do part B, I'm now working on them being independent. So we know for independent, that's when the probability of A times the probability of B is the probability of A intersects B. Okay, so let's have a look at what this one is going to look like. So the probability of A is 1 out of 2, and the probability of B is 1 out of 3, and that gives me the answer of 1 out of 6. So now we know what the intersection of A and B is, so we can go back and use that same formula that we've used over here, that the probability of A union B equals the probability of A times the probability of B minus the probability of the intersection of A and B. So we know that A union B is P. The probability of A is a half in this case, and B is a third. Oops, I think this should be a plus. I'm not sure why I'm writing times. And I'm going to subtract that 1 out of 6 that I've just found from over here. And I get the answer that P now is 2 over 3. And this makes sense that I get this 1 out of 6, because if we know that the probability of A union B is 5 out of 6, because over here the union of A and B is 5 out of 6, so it makes sense then that the intersection of A and B must be 1 out of 6. Okay, that's kind of a bit to take in. Play through the video again if you're really not sure, and we'll certainly go back over this in class.